Welcome to the Real Python Podcast. This is episode 68. Are you ready to expand your Python knowledge into the intermediate to advanced territory? What tools are awaiting your discovery inside Python's Functools module? This week on the show, David Amos is back, and he's brought another batch of PyCoders Weekly articles and projects. We discuss an article about the Functools module, which adds functionality for caching, function overloading, better definitions for decorated functions, and much more. David talks about a new Real Python article about working with complex numbers in Python. We also cover a tutorial about troubleshooting memory problems in Python. We cover several other articles and projects from the Python community, including DevOps Interview Questions, correlation analysis in Python, pivot and plot data with Pandas, how to use Python and OpenCV to play online chess with a real chessboard, and generating hardware pinout diagrams as SVG images. This episode is brought to you by Sentry, helping developers see issues that matter, solve those issues in minutes, and learn insights to keep their applications running at peak performance. All right, let's get started. The Real Python Podcast is a weekly conversation about using Python in the real world. My name is Christopher Bailey, your host. Each week, we feature interviews with experts in the community and discussions about the topics, articles, and courses found at realpython.com. After the podcast, join us and learn real-world Python skills with a community of experts at realpython.com. Hey, David, welcome back to the show.
Hey, Chris. Good to be back.
All right, I want to start off today talking about a topic that's bubbled up multiple times on the show already. And I think this is a really nice sort of post-mortem to the whole scenario. And it's an article that was written by Sebastian Ramirez, kind of covering all of the things that happened with FastAPI and Pydantic in the release of Python 3.10. And it's titled "The Future of FastAPI and Pydantic is Bright." It's a really kind of nice article, kind of discussing and really going into detail all the players. Like, if you thought outside of the box, so like, okay, who was involved in this whole thing? And everybody from people we've talked about, like Brett Cannon and Kara Willing, and along with Sebastian himself and the creator of Pydantic. So, if you're interested in kind of getting a follow up on that, and it really has a focus on typing and what. Mm-hmm. This move in some ways of, okay, well, lots of frameworks really want to use static typing and type checking and tools like that to be able to kind of help with coding. And that's really the big advantage of FastAPI, is it can really kind of help you plan for things like that as you're coding. And it also talks about just how popular FastAPI has gotten.
Yeah.
And how that might bump up against like potential what you might have thought, or maybe these are small changes in the language, and then suddenly everything breaks. And so, but the communications are open, and as they say, the future is bright, which is cool. So I think it's something that we don't need to dive too deep onto, but I wanted to just mention it as a follow up and include the link for everybody who want to check it out.
Yeah, it's a good read, and I think Sebastian did a good job really laying out like what the issue was, like what was going on, and then also like why the future is bright. Like it's I was just really impressed. I mean, I know there were some things with the communication could have been done better or done earlier, but ultimately I feel like it was a huge win for just the Python developers and the community.
Yeah.
Kind of coming together to solve a problem. And good stuff.
I always worry that sometimes when things get sort of focused, if you will, as the issue of the day on Twitter, that it becomes like a schoolyard kind of fight, and all these people are on the sidelines like fight, and it's like, no, that's not the idea here. So that's good to know.
Yeah
So what's your first topic?
So the first one I've got comes from Bartosz Zaczynski, and it's called Simplify Complex Numbers with Python. So Bartosz is one of the staff writers here at Real Python. I know we featured some of his articles in the past, but it's nice to see another one of his come down the pipeline. And this one is really, really neat. It's about Python's support for complex numbers, which if you've taken an algebra class, probably learned about like the number I, which is the square root of -1, if you believe in such things. I know there's a debate on all that in mathematics, but the symbol I, yeah, it's the number when you square it, you get -1. So Python has built-in support for complex numbers, which is a little bit unusual. There's not, like, I wouldn't say it's a common feature um, in languages to have it like literally just like you can create a complex number literal without having to import anything. Like it's just built in to the syntax. It talks about how you do that. And interestingly, or maybe not interestingly, if you come from an engineering background, but Python, instead of using I to represent the complex unit, they use J, which there's some good reasons for that, and that's explained in the article why they chose to do that. The article covers all the basics, doing arithmetic with complex numbers, creating them. There's a couple of different ways that you can create them. And there's a really fun section on using complex numbers as two-dimensional vectors. So this kind of goes back to kind of the understanding of complex numbers as really a pair of real numbers with a real part and an imaginary part. And you can kind of view them as two-dimensional vectors. The complex plane, as it's called, is a two-dimensional plane. And there's this really neat use case that Bartosz lays out in the article with an example of using complex numbers to represent cities on a map. So he uses the coordinates for cities to create like a vector for Miami, one for San Juan, and one for Hamilton, which he doesn't say where those. Oh, Hamilton, I guess, is a tiny island in Bermuda.
Okay. Yeah, I didn't know where that was either.
Yeah. San Juan is in Puerto Rico. Miami is in Florida. Yeah. So he walks you through doing things like calculating the magnitude of these vectors, which using complex numbers is really easy because there's this absolute value function, which will just give you the magnitude of that vector. So you get a lot of things for free when you do this. It's very straightforward to find the distance between 2 points, things like that. And then you can do all sorts of fun stuff like translating, flipping, scaling, and rotating. And you get all this stuff basically for free because of Python's built-in support. So I thought that was a really fun little example of how you could use complex numbers. You're kind of abusing them in a sense, like, but you get a lot of this stuff for free, which is really neat. Then he goes into talking about the CMath module, which is it's analogous to the math module in Python, but it's specific for complex numbers. So you have things in there like the complex versions of pi and tau and the nan, not a number value, and infinity. And you've also got functions for doing taking square roots and all that. So, but they all will accept complex number values as arguments, which the math module will not. So it gets into all that and into all sorts of stuff about, testing equality, how things are ordered for complex numbers, because the order is not as maybe straightforward as it is for like a real number, formatting complex numbers as strings. It's a really in-depth article, and I think it clocks in at around 10,000 words or so, maybe a little bit more.
Intense.
Yeah, but it really covers a lot of stuff. And at the end of the article, there's a nice example of like an application of these where you calculate the discrete Fourier transform with complex numbers. The example that he gives is not necessarily like the most efficient way to do it, and you would probably want to use something like SciPy or some other library if the efficiency is really important. But it gives you a really kind of nice look at how you can apply these the complex number support in Python to something, and the code is really nice. I mean, the support for complex numbers makes doing something like this pretty nice. So anyways, it's a great article. I think, if you're in the engineering space, if you're in the scientific computing space, if you're in maybe the graphics space and gaming space, this kind of stuff, you'll get a lot of value from reading this article. And if you're just curious about, like, if you didn't know that Python had support for complex numbers, just reading the first couple of sections, I think would really, benefit you, just so you're aware of, like, oh, that's how you create them, how you do the arithmetic and things like that. And like I said, this section on using Python complex numbers as 2D vectors is just really, really fun. I recommend anyone interested give that a read.
Nice.
Yeah.
It sounds like a really nice deep dive into all of that. I'm intrigued by the use of, like, maybe gaming and some other kinds of things.
Right.
Possibly.
Yeah.
So, yeah.
Yeah, exactly.
My first one is covering a topic that is a little more leaning toward the intermediate to advanced area of Python. And I always like to share some of these things to kind of, I've mentioned multiple times that when I started learning Python and I saw certain symbols and certain syntactic sugar and other things that were being used in the language, I always would like note those as like, okay, these, like, these are kind of like the slightly scarier areas where I'm like, I don't know what this is. And it seemed way more complex than it is. And I always want to kind of like stretch that boundary and keep kind of pushing into it. And if you're like myself in that kind of intermediate and moving toward more advanced topics, this is a really nice article that kind of gives you an introduction to a lot of it. And then I'm going to supplement it with some additional resources for you. But it's titled Functools. The subtitle of it is The Power of Higher Order Functions in Python. It's by Martin Hines, and it's another towards data science article. When I started to learn about this one, the main one that I learned in the package of Functools was the one for decorators, because I was doing my first course on decorators, and the Functools wraps and the other kind of language that's inside there, which is super powerful for using with decorators. But the idea is, as you create a decorator and you're basically passing a function into this other function, your original function's name, which you sat there and defined and potentially created a, like a string for and a repr for, to, basically explain and description of it. If you don't do anything about that, when it gets wrapped inside that other function, it unfortunately gets the wrapper's name. And so like you get sort of like a non-descriptive representation and string and so forth. And so there's this nice additional decorator you can add at Functools wraps. And that when you do that, it basically passes through all that. And then what I learned doing a little more research and going into the actual Functools Python 3 documentation is that it actually is using all these additional tools in it to do that. And I'm trying to look at their names again. It's a whole set called update_wrapper. And it does this whole thing, partial update wrapper. It has all these other parameters of wrapped equals wrapped and assigned equals assigned and updated. So it kind of does all this little bit of work for you without you having to do all that background kind of stuff and learn a lot about it. You can simply apply it.
Yeah.
And I didn't even understand all that at the time when I was doing my decorators course, that all this was happening behind the scenes. So lots of really powerful functions being applied to functions stuff.
Yep.
It goes further. There are a lot of other areas. There's caching, which I think is really powerful and, again, kind of a performance thing.
Yeah.
And it's actually been updated quite a bit. And in Python 3.9, there's a new version that's just called caching. The previous one was the LRU cache, which is a little confusing of a name. LRU means last recently used. And the idea there isn't to keep the last recently used around. It's actually to toss those ones out. The idea is like if you are, maybe it's like a website and you have a bunch of blog posts and you want to keep the ones that are really popular, around, that these ones have been used a lot recently and have been looked at a lot recently, and these other ones have not been paid attention to. And you can think of this again in your own programs, like as far as like values and dictionaries and things like that, that these are the things that are being used. I should keep these cached and ready to go in the background. And the ones that are least recently touched or used, we can go ahead and we can toss them out. So
right.
We have a great article on that, and I'll include a link for that, a whole separate real Python thing on LRU cache. And then there's, other stuff like cache property and reduce, which is a very powerful thing where you can apply a function to an iterator. And it's, I want to go into depth in each one of these, but probably the other one that I think is kind of fun, because we've been talking a lot about these dunder methods of like double underscore EQ, which is, like defining inside of or overriding inside of a class, like, what does equal mean for this thing? And it's called total ordering. And what that will do, if you define what the comparison will be for something to be equal, and at least one of these others, like a less than or a greater than or less than equals or greater than equals, if you define equal plus one of those, it will go in and define all the rest, which is pretty slick.
Yeah.
So it will create all that other information and ordering of operators and comparisons and so forth. So it's a really powerful module. Lots of stuff kind of hiding inside there for the intermediate developer to learn more about and dive into. And I really, along with this article, which I think is a nice survey and has some nice code examples, the Python 3 documentation is excellent on it. Actually, it has other additional nice examples. So like one of the examples they use for cache is like if you have a factorial type of thing, this sort of recursive example, and we go through and say, do a factorial of, say, the number 10. And then the next time you called it, it did the factorial of 5. It would just actually go ahead and look up all the cached results.
Yeah.
And then if it did, say something that had more factors in it, like factorial of 12, it would actually only need to do 2 new recursive calls upon it. The other 10 would already be in the cache. So like,
right,
nice examples like that. And with code that you can kind of practice and run and maybe try your own skills at, okay, well, how could I gauge the performance of that compared to it having to generate those again, as opposed to reading from the cache of that. So pretty slick. I enjoyed it. I thought it was a nice tour of these additional, tools that you can add to your tool belt and kind of expand what you can do inside of Python. And I'd only had scratched the surface myself.
Yeah, there's a lot of nice stuff in Functools, and I feel like it's one of those ones that when you first, like if you come across it too early in your Python journey, you're kind of like, what is all this stuff? Like, I don't.
Yeah.
But when you reach a certain point, you start digging in, and it's like, oh wow, this is going to make my life so much easier. And yeah, the caching stuff is really, really great. You can also do like function overloading.
Yeah.
There's a single dispatch decorator that you can add to functions that will allow you to basically write multiple functions with the same name that take a different type of argument, and you can not have all that code for like, if it's if the argument was of this type, then do this thing, and if it was of this type, then this do the other thing. Partial is another one that I've used quite a bit in the past. That one's really fun. And I think that I think Real Python has articles on a lot of different things that are mentioned here.
Quite a few of them, yeah. I'll try to gather as many as I can.
Yeah, definitely.
To kind of give you highlights with some additional stuff.
But yeah, this is, like you said, it's a nice just tour of what is in there, and what's in Functools, and some little examples of how you can use it.
Yeah, so if you're looking for learning a little more, here's an area that you can kind of keep expanding your your Python growth.
Definitely.
This episode is brought to you by Sentry, helping developers see issues that matter, solve those issues in minutes, and learn insights to keep their applications running at peak performance. What can you expect from Sentry? You get actionable insights and full context so you can fix your app's errors and optimize its performance. You get performance monitoring. Engineering managers and developers now have a single tool to trace Python performance issues back to poor performing API calls, as well as surface all related code errors. And with Sentry's error monitoring, you can understand the important events that led to each Python exception, be it SQL queries, debug logs, network requests, or past errors. Spend less time fixing bugs and more time building features. You can learn more at sentry.io/for/Python, or you can click the link in the show notes. What do you got next?
Next one I've got is called How to Pivot and Plot Data with Pandas. And this comes from Stephanie Mullen, who is a data scientist at Bloomberg and author of Hands-on Data Analysis with Pandas. And this is a really nice article. It's not too long, and so it's a nice kind of quick read, but it gives you an example of using real-world data, using 2019 flight statistics from the U.S. Department of Transportation's Bureau of Transportation Statistics. She's got a link to the data set to kind of look at and analyze like the top 10 most popular flight destinations in the US. And she mentions it's got 321,409 rows and 41 columns. And she kind of goes through like how you read the CSV file and just kind of, taking a look at like what are all the column names and kind of getting a feel for what's in there. And then kind of working your way through by changing the shape and everything and doing what's called a pivot on the data frame on the table to reshape things, get rid of columns that you don't need, and wind up with a nicely formatted little data set of the top 10 destinations. Then from there, it gets into plotting and making a horizontally stacked bar chart with like passenger totals that are colored. Each bar chart is like the total number of passengers that traveled to a certain destination. And then within the bar, it's like color coded by carrier. So like blue is American Airlines, orange is Delta Airlines, and so on. And yeah, it's just the code is like top notch. If you're looking for like, how do I write idiomatic Pandas code to do this kind of stuff? It's a really, really great resource for that. And something else I want to mention is I mentioned she has this book, Hands-on Data Analysis with Python. And I also want to mention that she's got this Pandas workshop repository on GitHub that is from a session that she ran at Open Data Science Conference or ODSC Europe this year, 2021. And it's got similar kind of stuff that's in the article, but goes into a lot of different topics. There's like a section on getting started with Pandas, a section on data wrangling, section on data visualization, and then finally like a hands-on data analysis lab. So I'm not sure if there's a video or anything there that you can watch.
Yeah, it looks like it just occurred on June 10th.
Yeah, it's a recent deal. But yeah, the repository that she put together for it has like all the code from these sessions she ran. And again, just like a really, really great resource for anyone out there trying to learn Pandas and look for examples of like really high quality Pandas code. So hats off to Stephanie. I think the article is really great, and she's got some really amazing resources on her GitHub profile.
Nice.
Yeah.
All right. Well, what I have up next is it's actually a GitHub repository, and it's kind of hiding underneath it is a lot of really great Python stuff.
Yeah.
It's titled DevOps Interview Questions, and it's pretty huge. Like there's 48 different contributors. It's maintained by Ari Bregman, and it has over 11,000 stars. So it's a pretty popular repository there. And currently it has 1,575 questions. That may change. And like I said, there is a Python section, even though it's kind of geared toward DevOps. And what I liked about it is, people always kind of wonder like, okay, what we're trying to prepare people to be able to take a Python interview. We've talked about that as far as like potential coding things and practice problems. But this has some other kind of like general questions that I think would be really good to kind of like suss very quickly. Okay, this person seems to understand, what's happening with the language. What are some of the quirky things? Like we had that recent JavaScript course that had tons of like, how Python compares to JavaScript and what's quirky about it and different.
Yeah.
And so some of those are like, well, these are some of the quirky things about Python, which I think is interesting. And I like some of the questions that are in that section. There's a good little section on Python, but then there are sections on all these other areas that if you're going to do DevOps, you should be somewhat familiar with. Like the Linux questions actually dive into, things like, okay, well, what are these basic commands like touch and ls and rm and cat and, and being able to kind of, sort of understand what's happening with them. And what I think about is if there are areas that you feel like you would like to learn a little more about, and there are a huge, there's a huge area that's covered here. And I think about this, and I mentioned this with the last episode, where sometimes you just don't know what you don't know. And is there a way that you can kind of reduce that area?
Right.
Like you can kind of get the scope of it and then like, okay, I want to tackle this kind of area. Like I don't want to learn everything about DevOps. Like maybe I'm not interested in Kubernetes. Maybe you feel like that's not something that, your business would be involved in, but I should know about Docker, or I should know about, these other kinds of tools. Like I should know like the basics of Linux. I should be comfortable with some of these things and like, okay, well, what even are the basics of Linux?
Right.
Like there isn't very often when you get to a book, there's like sometimes this whole like traversing so deep into the book to even get an idea of like, well, I just want to know like, what should I know like generally about some of these topics so that I can be conversant and be able to make sure that when I have an interview, I don't sound like I'm just making stuff up, which I've seen people do in an interview, which is very bad. It's like, okay, very clearly this person is trying to bluff their way into, their position here. And so I liked it as a neat repository. And I think it's a good resource for someone. And we've talked about DevOps quite a bit here because of so much, if you want to do data science, it kind of crosses over very often to this idea like, okay, well, you may need to do that with a cloud service, or you may need to do it here, and depends on the size of your data and so forth. And I don't feel like the questions were all that hard. They weren't like super specific. Like some of them were, as I glanced through them, okay, I understand that. Like, and again, I'm not a DevOps engineer, but I feel like I understand what, what's happening here. So I just found it as a neat resource, and I really wanted to make sure we shared it. Again, kind of reinforcing that idea of like, what, and the other one was like, a lot of them could be like idea generators for projects. Like if you want to, again, build little projects, the idea of like, okay, well, what would be the basic structure of like an uptime bot that would basically, make sure that this website is staying up and so forth. Like what would that look like? And what would be some of the packages you would use in that? And so yeah, I just really liked it. I thought it was a nice resource that is going beyond just the idea of purely DevOps.
Yeah. And you brought up kind of a good point that I kind of want to just expand on for a second, because I think that it touches on actually a discussion that we had internally at Real Python while reviewing an article, an upcoming article, and that is kind of like a model for learning,
right?
Like psychologists and things that have studied this. And there's this interesting model called the 4 stages of learning. And I forget it was originally established by Gordon Training International in the 1970s. So I don't know. It sounds like a consulting firm or something. I'm not sure who.
Yeah, potentially. Yeah.
Who the actual person was.
It's just Gordon.
Yeah. But it lists these like 4 stages in like the journey of learning. And I think it's kind of neat to be aware of this. And the first one is unconscious incompetence. And it's exactly what you mentioned. It's in this stage, the learner does not have a skill or knowledge set yet. It basically is you don't know what it is that you don't know. You're incompetent in some area and you don't know that you're incompetent yet. And that's like the first phase of learning. And to get to the second stage, which is called conscious incompetence, that's where you're aware of a skill that you lack and you understand that there's some kind of deficit there. You need someone or some resource to basically say like, look, here's all the things. And yeah, this DevOps exercises repository can exactly do that for you. And then I guess just to like lay out the rest of it, after the second stage of conscious incompetence, you graduate eventually to what's called conscious competence.
Yeah.
And that's where you've acquired a skill, but you've not yet mastered it to the point where it comes naturally. That's the 4th stage called unconscious competence, where it's basically like it becomes second nature. And it's like the phrase of, it's like riding a bike. You never forget how to do it, kind of a thing. And then there's some theory, I guess, that some people have laid out that there's actually a 5th stage, which they call conscious competence of unconscious competence, where basically you're able to kind of relate 2 other learners that are in the first 4 stages and teach them.
Okay.
So you've sort of like got this meta understanding of what it is, and you're able to relate that then to people who are in lower stages than you are in this learning pipeline.
That's cool, because I feel like teaching is such a great way to learn something too, and confirm that you've learned it. And it's sort of that crossing over point of that, somewhat like being able to watch somebody else and go, I see where I can help, or this could help. These are the resources to get you there.
Yeah, exactly. So yeah, I just wanted to highlight that because I found it really kind of fascinating, but also like super relatable. Like if I think back to the skills that I've learned throughout my life, it's kind of like, well, yeah, I kind of clearly see these 4 stages, and it's not always easy to know like when you've actually crossed over from one stage into another. And it doesn't happen like all at once, right? Like like especially when you're learning something as complex and in depth as the Python language, or something like DevOps, which is a lot of things all together. It's not just like
the topic
skill.
list. Like if you wanted to know like what are the subsections, it's like, okay, it doesn't even fit on one screen on my computer monitor. It's like, okay, generally DevOps, Jenkins, Git, Ansible, network, Linux, Terraform, programming, generally Python, Go, scripts, Kubernetes, Prometheus, Mongo. Do I need to keep going? There's like, again, so many more containers. They have a regex section, regex, however you want to pronounce it. So a virtualization. Yeah, it's just crazy. So there's a lot. And again, and then there's just a funny one, like general questions that maybe you should ask them, because that's always one of those things that they turn it around on you in an interview. Like, do you have any questions for us? And some of those are good.
Oh, that's cool. Yeah.
Yeah. I think those could use some more work, personally. Like I have other ideas there, but it's nice. Yeah. Cool.
No, you should contribute something.
Yeah, I should like, here's questions that I would ask of an employer. This week, I want to shine a spotlight on another Real Python video course. It's about a topic we touch on this week, and new students to Python can often find a bit confusing. It's titled Python Decorators 101. The course is based on a Real Python guide by previous guest Gerana Yella. And this one's a course by me. And I take you through how functions are first-class objects in Python, how to return a function from a function, how to create simple decorators, adding syntactic sugar when using decorators, how you can decorate functions that have arguments, and you'll practice creating several real-world examples of decorators, including code for timing your functions, debugging code, slowing down code, and a plugin registering system. I think it's a worthy investment of your time to learn how to use decorators and to recognize how decorators are being used in all the code you encounter on your Python journey. Real Python video courses are broken into easily consumable sections, and, where needed, include code examples for the techniques shown. All lessons have a transcript, including closed captions. Check out the video course. You can find a link in the show notes, or you can find it using the newly enhanced search tool on realpython.com. All right, so what do you got next?
Next one I've got is called Correlation Analysis 101 in Python. This comes from Olga Berezovsky, and she's got, as far as, well, actually, I should double check real quick. It looks like, so it's on this website called Data Analysis Journal. It looks like it's her website, like a blog or something like that. It looks like she's the one that's written all the articles for it.
Yeah.
But this one is really neat. It talks about doing correlation analysis, which is basically where you're trying to, like, if you have a data set with different features, which are like maybe like the columns in your data set, and you want to know, like, is there any relation between two of your columns? Are they somehow related to each other? And you might want to know that for lots of different reasons. I mean, you might be curious about, like, is there a relationship? Or you might also be looking to, like, can I just remove one of these columns? Like, because the information from one is kind of encoded in the other one because there's this tight correlation between the two. She goes through, like, what correlation analysis is and why you would want to do it, and then how to do it using Pandas. There is, if you have a data frame object, you can also do it on a series as well, but she only focuses on, well, you can't do it on a single series because a series is like just a single column. And so you would correlate two different series. She focuses just on the data frame version, which is a method on a data frame object called the core method, CORR. And when you do that, you basically get a new data frame back. It's like a correlation matrix. So it's got, all the columns on the column titles on the left-hand side, and then also like for each row, and then the columns at the top. And the intersection of those columns and rows are like what the correlation value is between those two columns in the original data frame. She gives you a neat way to visualize this correlation matrix as a heat map.
Yeah, I like that.
Where things are kind of color coded, so you can very like easily, because if you're just looking at a giant matrix of numbers, like it's not always the easiest thing to look at, and it might take you some time to kind of like recognize like, oh, okay, there's a big number, I should pay attention to that. Whereas if you put it in a heat map, then things are color coded, and like, oh, if I look for certain kinds of colors, then I know that we've got things that are highly correlated or things that are not very correlated. She gets into how you actually read these and everything. But what I really liked about it was at the end, because there's this one of the things you have to be careful of is just because you find two features in a data set that seem to be highly correlated does not mean that there's any kind of like causality relationship between those two things. This whole like correlation does not imply causation kind of thing. So you have to be careful. Like it could just be you have too small of a sample size and it was just kind of a coincidence that things look highly correlated, or it could be that there really is they are correlated on something, but like somehow they're totally unrelated and it's just sort of like a false positive kind of situation. But she gives you some tips of things to look for so that you can like decide, is there potentially some kind of like causal relationship between these two things? For example, the strength, if your correlation coefficient, which is the number you get when you do this correlation analysis, if it's really high, that could be, and it's statistically significant, that could be an indicator that there's some kind of causality there. Consistency is if you're able to like replicate this, like if you're working on like a small sample size from a larger data set and you go in and take another sample and you get the same kind of correlation and you're able to replicate this many times, that could be another indicator. Things like temporality. So if you're able to notice that one thing always happens after another, like if you have two features that have like a time component to it in your data set and you see like they're related, they're correlated, and also feature X always happens before feature Y, that could be another indication. So yeah, there's a whole bunch of different kind of tips that she gives you here. And I'm not sure if she mentions it. It doesn't look like it's mentioned, at least in this section, maybe in another part of the article. But, you should never go off like a single indicator, right? Like if you're looking for that causality relationship, if the only indicator you have is that the correlation coefficient is like really close to one being like the highest it could possibly be, that's not necessarily a good indicator. But if you have like 3 or 4 or 5 things all kind of adding up, it's kind of like, okay, well, maybe this really is worth investigating and we should, maybe take a look at that. It would just give you a lot of evidence that there really would be some sort of causal relationship there. So again, it's a pretty short article, but just full of really fantastic tips and with code examples. So definitely a good thing to check out.
Nice.
Yeah.
The trick of like not falling into that correlation being causation and
right.
Yeah. I'm intrigued by her blog. There's some interesting stuff on there. It's a Substack. So it's like a subscription thing. So there's different free ones. And it's funny that one of her examples is like
the real Python.
Yeah, I saw that, but also then I just
saw that.
Yeah. And then I saw one that was like, determining like, okay, well, based on how many comments, how many people, did they subscribe if they wrote a comment, and all that kind of like analysis, which is sort of an interesting thing, sort of dog fooding her own thing there. Yeah. But then there's the questions about the data analyst article that we had. All right. Well, my next one is kind of going off of a theme that we've had in the past, some stuff with Idemar Turner-Trauring.
Yeah.
He was on before talking about Docker containers and, making sure that you're picking the right, packaging solution and some other things. But he also is really into sort of studying memory usage, kind of what's happening with it. And he's built this memory profiler called Phil. He's got a new article that I'm not focusing on, but it's kind of diving into the topic and measuring memory usage in Python. And the subtitle is "It's tricky," which I think is good, which is true. But the article that I wanted to focus on is sort of this, again, kind of a bit of a postmortem, this how to troubleshoot memory problems in Python. And it's by Freddie Boulton on Innovation Labs. They have a tool called eval-ml. And they were having a tricky problem with their own library and trying to figure out what's going on with it in a particular project. And the focus of the article is like why it's important to find and fix these memory problems in your programs. And then it really goes into this idea of like, okay, well, is there a way to figure out sort of what are called circular references? This idea that something isn't getting released. The memory usage in Python is not something that you directly control in your programming unless you're doing some higher order sort of stuff. Like in C programming, in some other programs, you're actually going in and you're allocating memory, and then you have to remember to unallocate it and free it up and so forth. But inside Python, it uses what's called reference counting. And as long as there's a reference to something, it's going to keep it alive. And if not, then it gets garbage collected and frees up the memory. And so it's possible that there's something in programming or potentially other packages that you're using where this reference is, still happening, and it's getting referred to again and again, and potentially creates this explosion where like you get this strange dying of your program that's also typically like silent as far as Python's concerned. It just crashes.
Yeah.
And you don't necessarily see some kind of like trace or other kind of thing happening. And so I like the step-by-step sort of flow of the article. He starts off talking about, okay, well, what is a memory leak, and diagnosing, like, okay, what are the potential things there? And then goes right into like, okay, establishing, is it an actual memory problem, this problem that I'm having? And there's a Python memory profiler that he references, and I'll include a link for that. And what's nice about that memory profiler is it creates a plot of usage over time. So you can kind of see as the program's running. In this case, he was working with this 4 gigabyte file, and then, it was running at kind of a nice plateau for quite a while. And then it just started to peak and just like suddenly, went and doubled its memory again and again. And in the case of, some computers, or if it's a, container or other kind of virtual environment, or some other kind of situation where you've set up this other machine, it's possible that, okay, it's going to eclipse that memory and suddenly, crash. And so that's a nice tool for that. And then going back in the next section was like reproducing the problem and kind of figuring out, okay, what's my minimal example so I can kind of profile this thing and watch what it's doing. And again, using the memory profiler, he's watching it with like a smaller subset of the data and trying to see what's happening there. And then he actually uses Edamar's fill program, and it's nice to see the output of it again, because it's funny how that program will then show you like actual lines of the code.
Right.
Where memory's being used, and the more red it gets, the more memory is being used. So you can kind of like almost your heat map thing again of like, through there, and it has lines of code. The actual lines usually get deeper and longer as the more memory is being used. Then it goes into like, okay, now you found potential lines of code where this stuff's happening. And then it's what is actually leaking. There are these leaking objects. In this case, he's found this circular reference, and it was from another package, and he was able to communicate with them to say, hey, I found this weird thing happening. He actually uses another graphical tool to figure out like what's happening in there and sort of point out what's referencing what. It's really slick. I'd really like it as a nice way to, again, step by step, if you wanted to find a way to troubleshoot memory problems. And then the final one is just, as you should, verify your fix and go through it and again measure what's happened and verify that you've actually fixed what's happening. And again, smaller programs, you may not have that, where you're like, again, people doing more like script type things. But if you have a program that's long running program, like some kind of web service, or in the case very often of like data science things where it's going through lots of iterations of something, and there are large data sets, it's very Well, it is possible to, have stuff sort of explode suddenly and use up all your memory and crash. So I like these two articles as ways to kind of get a better handle on that.
Yeah, it's I've not really run into these kinds of issues much in my own work, but I do know from stuff I did, like when I was studying computer science at university. I mean, measuring memory is not easy, I think, in any language. Like these memory issues, like it's a very difficult thing to debug in general, not just Python. But what was really nice, like you touched on this too earlier, is that this article really gives you kind of it's something that actually happened, looking at a use case of this fill profiler and another tool, the memory profiler tool. And yeah, it was kind of the first article that I'd come across, because I've kind of been following along with Phil for a while just by reading Itamar's blog. But this was kind of the first article I'd come across that really gave like a really detailed explanation of how they actually used it to track down a real problem. And I really like the step-by-step framework that they've kind of put together as something that you can use in your own situation if you come across something like this.
Yeah. Well, that brings us to projects.
Yeah.
You have kind of an interesting one that might be a future one as far as like setting up. It sounds like it requires a little bit of hardware on your side to try out. Can you explain this one?
Yeah, I wasn't able to really try this one out, but I'm really intrigued by the idea. It's got a long name. It's called Play Online Chess with Real Chessboard, all hyphenated together.
Right.
It uses the OpenCV library, which is a computer vision library, to basically, the way I understand it, looking at the README, is there's a little bit of a process to kind of get everything set up. And it really would help if you have like an external webcam that you can like put above like an actual chessboard. So you need a chessboard and chess pieces, and you need a webcam, and you need to be able to set the webcam up like so it's looking down over the chessboard. But it'll recognize the corners of the board and recognize all the squares and sort of like lay everything out for you. And there's like a calibration script that you run to get it to do all this. And then you place the pieces of the chessboard in their starting position, and then you run the main program. And then it'll basically, like, you can make a move and it'll detect it, like what that move was, and track it. And then there's an online component where you can be playing against an opponent who can like be looking at the chessboard as well. And they can say to you, like, I want to move, my knight out to, this square or whatever. Right. And then you would basically like input that into the program, and then you could make your move, and then they could, and then everyone can be looking at the actual chessboard that exists on, on a table somewhere that you've got it set up. So definitely like a neat application of OpenCV. I thought it was a really fun idea and a cool project. Definitely something to check out. And it kind of highlights like the kinds of things, like if you're looking for ideas, right, of projects, like, yeah, I don't know what this person's experience was with OpenCV and everything beforehand. Probably they read some tutorials. I don't know if maybe they're masters of OpenCV. I have no idea, but I can imagine just like by doing something like this, they learned a ton about OpenCV and Python, and there's so many components to this. Like there's even a graphical user interface that they created for it, and so yeah, it's just a really fun little project, and would be an interesting. My guess is, well, you can go download you can clone the repository and get this set up. But I would imagine that coming up with this was more than just like a weekend project. This looks like they spent a lot of
yeah, it sounds like
a lot of effort, yeah, into all this. But yeah, just really neat. I love the idea, and just wanted to highlight that.
And it doesn't require you to take drugs and imagine stuff on the ceiling. Like Queen's Gambit.
Oh, gotcha. I haven't seen it.
I don't think that's a spoiler. I'm pretty sure that's in the trailer. All right. Well, my project is called Pinout. And I know I've been talking a lot about hardware lately, and this is right up my alley as far as, describing what different physical hardware does, as far as, the actual pinouts for, let's say, like an Arduino board or one of these Featherwing boards or other things that you might get from Adafruit. And so it just allows you to generate the pinout diagrams, and it creates them as SVG images. It's a project from John Newell, and he's got another collaborator on there. And he actually went through kind of a whole list of things. I like the sort of last page of the docs. He's like, things the creator tried. Export it from KiCad. And we've talked about KiCad a little bit before. This is a tool. We talked about it in about Winterbloom and Stargirl Flowers, and how she's using that to create boards and stuff like that. And so that's a popular tool for actually creating circuit boards and their designs. So actually just exporting it from there. He had another thing he tried, which is just create them from scratch, use Inkscape and Illustrator and export the elements from KiCad, taking a photograph. And then one other project that he mentions is called PCB Draw, which is actually kind of a hybrid of those things. It's exporting things from KiCad and then creating SVG versions of what the board would look like in the pinouts and so forth. And then a tool that I found recently, which is called Fritzing. I saw a PyCon talk by Nina Zakharenko about CircuitPython, and she mentioned Fritzing. And I think I'm going to be using that for some of my tutorials. It's a really nice tool for kind of showing wiring, but also showing external things plugged in. So you can say, okay, this is where you'd add a switch, and this is where you would have the output of that to an LED. And it's a very nice kind of graphical layout. But this is a nice one in the sense that if you want to explain to somebody else, what's happening with this circuit board, what do these outs do and so forth. And it does all the heavy lifting of creating the SVG file, what all the little boxes and labels are going to be. It creates a legend on the side with a whole sidebar of boxes with legend, description, notes. If you follow using the example in the tutorial, you just sort of need to know the relative X and Y's of these layouts to know where the pinout sort of breakouts should be. It just does all that stuff, which would be very annoying to try to do by hand, which it sounds like he tried in the past. And the one thing that I noticed about it is, as an SVG file, it's not super friendly with other SVG tools that I've used. I did not try to open it in Illustrator, but I have a couple other lightweight tools that let me create SVGs. I've made logos and other things in that format. The idea of this sort of scalable vector graphics, the non-raster thing, so you can kind of make it any size. But this definitely opens up really nicely in a web browser. So if you were going to, create these kinds of things that would be embedded in a web page, it not only has the SVG, but then it can have references to actual PNG elements, the actual picture of what the hardware is with it, other SVG elements overlaid on top of it. Anyway, I like it. It's a neat little project. It's something I might use myself to kind of create some explainer kind of things, what's happening with this hardware. I'm intrigued to see what happens with it in the future.
Yeah, it looks really cool. I like the style of the images that it produces.
Yeah, it's very pretty. I think it is not only informative, but it would look nice and not be. Sometimes electronic stuff can look either a little too cartoony or a little too just not clean. There's kind of a technical way things can look sometimes that it's not stylish.
Yeah, you need a electrical engineering degree to understand it or something.
Yeah, that too. Right, exactly. So I like that about it. And there's so much that these boards can do. It's it's just labeled pin 1. And you're okay. Well, it can be a PWM output, or it can do this, or whatever. And so having kind of a little better idea of what this thing can do, and printing all that out in a nice map of what these pieces of hardware can do, I think is really useful.
Yeah.
So, all right. Well, and that brings us to the end of another episode here. Thanks for all the PyCoders goodness that you brought along.
Yeah. Thanks for having me back.
All right. And I'll talk to you soon.
Yep. See ya.
This episode was brought to you by Sentry, helping developers see issues that matter, solve those issues in minutes, and learn insights to keep their applications running at peak performance. You can learn more at sentry.io/4for/Python, or you can click the link in the show notes. I want to thank David Amos for joining me again this week. And I want to thank you for listening to the Real Python Podcast. Make sure that you click that follow button in your podcast player. And if you see a subscribe button somewhere, remember that the Real Python Podcast is free. If you like the show, please leave us a review. You can find show notes with links to all the topics we spoke about inside your podcast player or at realpython.com/podcast. And while you're there, you can leave us a question or a topic idea. I've been your host, Christopher Bailey, and look forward to talking to you soon.